Yo, what's up, you guys? Welcome back. Today, we are trying to render some emoji fonts. My monitor broke. It was like 20 years old. The clocks finally stopped syncing up well, and it doesn't turn on anymore, which means that I can't put my Twitch chat on the second monitor. And that means that, of course, the only solution to that is that I have to write my own Twitch chat client, because I'm hiding the web view right now underneath my camera. But I have to do a bunch of inspect elements to remove a bunch of clutter in the UI to make it usable. That's annoying. So of course we write our own Twitch chat client. Sometimes people send messages with emojis in them. Like they might send me the upside down smiley face, right? Maybe we want to look at upside down smiley face emojipedia, right? And I want to render something that looks like approximately like this. Maybe not with the 45 ads in the way, but we want to be able to render something like this. And so the question is how? How is that done? Right now we have some form of text rendering, right? This is all kind of hand rolled. But here, if I try to render the string test upside down smiley face, upside down smiley face, we pull from a font file. This font file has basically a definition of glyphs, we can say. And if I remember correctly, which I probably don't, this is all kind of hand wavy because last time we worked on this was a long time ago. It's going to define curve segments, right? So this T is probably going to define a line, and then a line, and then a line, and then a line, and then a line, right? And then here it's probably going to find another line, but then here it might define a Bezier curve, right? So there, a Bezier curve is defined as there's 3 points, there's 2 handles and a center point or something. I don't really remember. It's something along the lines of if you interpolate from A to B and B to C, and then interpolate along the line that is formed by those 2 points, you get a curve that kind of it touches or something. I don't remember. But he defines basically a list of curve segments. So like this, right? We do something a little fancy here. We took some inspiration from a paper from Valve, if I remember correctly, that basically says instead of just rendering this thing directly, we generate a distance field of this thing so we can feather the edges, right? So if you look, we zoom in here, we don't have perfect. The pixels are kind of faded on the edges. That is not really defined by the curves that the TTF file gives us. What we are doing instead is we say for each point in this, inside or outside this line, really, how far are we from an edge? The things that are inside get positive numbers, the things that are outside get negative numbers. And the way we do that is if we open up Blender, it's kind of the easiest way to show it. We kind of can abuse the 3D rendering pipeline. So if we make a cone in here, and we kind of put this kind of just around the shape of that T we just made, right? So kind of something like this, right? Just we're drawing a T with these cones. Please forgive how bad this looks. We're just trying to get an approximation of the idea here. Oh my god. Okay, let's move this. We need kind of the fin at the bottom, right? This type of shit, right? That looks kind of like the T. I mean, really, this stuff needs to come farther out. We need kind of more stuff in here, right? Imagine that that's a good representation of the T, right? What we do is we kind of do this, where we sample along those curve points, and we make this 3D mountain of all these things. And basically, if these points are close enough together, then the depth at any point is the distance from an edge, right? So imagine that we had sampled this way better. We have kind of a distance at each point. And what we can do is we also render a mask of the inside of this thing, where anything that is inside the mask gets inverted. So all of the cone points inside would actually be higher up. And then we can basically threshold and say, do some sort of smooth stepping around the edge, essentially, to kind of make the feather effect that we have here for font hinting or whatever. Anyways, that's what we do right now. Ish. Probably. The question becomes is what the fuck is this, right? This does not, as far as I understand right now, fall into that pattern. So the thing that we want to do today is open up the Google Noto Sans font, wherever the fuck that was. Google Noto fonts emoji color, whatever the fuck it was called. Hello, there we go. Open up this font file and try to render some of the stuff in here, right? Presumably it's going to be very different. Presumably. We don't really know. We took a very, very, very brief look at this the other day. And by very brief look, I mean we opened up the font file for the Google Noto emoji color font data. And we just kind of dumped the tables in this thing. So the font file is made up of a bunch of different tables with information in them. So like the glyph data that we had for this, for the like the letter T and stuff like that, that was in some table titled glyph. And you can kind of tell because like this guy is like an order of magnitude bigger than all the other tables in there. If we look at the Google Noto emoji font, we see there seems to be some glyph data, which is quite large, which is interesting. Maybe that's for fallback, I'm not sure. Maybe the glyph data is still used in some combination with the other stuff. But then if we look around here, there's also, interestingly, an SVG segment. So theoretically, we could probably write like an SVG renderer, and then in here, there's probably SVG data that represents that. But there's also a lot of data in this like color segment. And so I started looking up, COLR font stuff. And you come over here to like this page from Microsoft, and they're talking about emojis, right? So presumably this is related as well, right? So the plan for today is to just kind of start like ripping in, looking at this color stuff, and trying to figure out if we can find where the data that we're looking for is. Maybe we try to render it. Maybe we just figure out what the format is. I don't know. I don't want to render this. I don't want to read this giant page of shit yet. So I think what we're gonna do is we're gonna start with the data, right? Somewhere down here, there's going to be just like, hey, this is what the data looks like, and we can start here and from there try to render something. And if it looks like shit, then we'll have to read a little bit more. But I don't know. So let's start with trying to parse out the color section, because it looks interesting. It looks interesting. Where did my fucking OBS go? 0750. COLR. Oh my god. COLR. Okay. Did we lose? Oh, this one. Here we go. This one. Okay. So we have the color table begins with a header. Two versions have been defined. Version 0, which has the version set to 0 at the beginning, or version 1, which is the version set to 1 at the beginning. So I guess the first thing we have to do is we need to check the first uint 16 and see what's in there. So color is probably a color table if we're just going to be following the examples of what we see in here already. And what do we do here? It looks like what we were doing before is we were making packed structs that had just probably the order of these fields in them. Can we look at one of these other ones and see if it was top to bottom or what? So on head table, we had version as a fixed point, so to a U32, right? So this is a major, minor, or something. Font revision, which we had as a fixed. This is slightly different, but like whatever. UN32, checksum. Yeah, okay. So it looks like we can just take this and slap it into a packed struct. That's what it looks like. That's what it looks like. So let's just put it next to this guy. Pub const color table is a packed struct. It looks like maybe some of these other guys we choose to do something else, like maybe we parse manually, but the vast majority of these we're parsing like this, so we'll do that. Version U16. Num base glyph records U16. Is offset 32 a type we have defined right now? Not as far as I know. What is an offset 32? What is an offset 32? Do these get defined somewhere? I mean, we can assume that this is a 32-bit maybe signed. This must get defined somewhere. Do they have maybe types in here somewhere? Open type spec. I think that open type and true type are not exactly the same, but I think that they're like the same enough that we can be using this. I think. Oh, here we go. Perfect. Offset 32. Long offset the table. Same as U32. So it looks like it can only be positive. Okay. Base, glyf, records, offset U32. And layer records offset is a U32. And then we have num layer records here. Oopsies. Okay. Cool. So does this, like, this is only the... Wait, what am I fucking smoking? This is color table V0. But we're probably V1. So can we actually just parse out... can we just parse out the version first before we do this? I'm probably smoking some shit right now. Okay. So, what was happening here? It looks like we parse... Okay, for table entries, we have some directory, right? And here we have table from entry, which takes the font data from entry. So if we see color, we should be able to just kind of yoink out table from entry like this, I guess. And this should give us like color data bytes or something. And we should be able to just look at the first thing. So can we pull out some header tags here, color like this? Except it's supposed to be in all caps, right? Then can we maybe just print this for a second? Maybe just print like the first 10 bytes or something. I think that'll give us some interesting info. And I'm assuming that it's more than 10 bytes, but maybe it's not. Okay. All right, let's see what happens here. That builds, beautiful. And it looks like we do see this thing, right? So we're probably seeing version 1 here is what we're looking at, I would bet. If we try to make a color table, which we just tried to do, but I forgot that we need to maybe do something like color table common, maybe is what we're looking for, and we just do like version. I guess we don't even have to do that. We can just do, what does fix endianness do in this function? I assume that this is flipping things. I see. It's flipping from big to little endian. So everything that we get in is big endian, and we need to flip it. So if we did like bytes to value, and I'm looking for a U16 that comes from the first 2 bytes of this guy, right? Probably something like this. And we want to print this as a number. We probably want to do something like what was it? Big to native. Something like this, right? Convert this thing to a number that we know how to handle. Okay, something like this. So we should be seeing version 1 here. Oopsies. Am I stupid? Maybe we new line here? Yeah, here. We see version 1. Version 1. So this is the guy that we should be looking at. Oopies. Oopies. So I guess we say version is this. Whatever the fuck we just wrote here. And we'll say if version is not equal to 1, return error unsupported or something. Or maybe, yeah, we'll figure it out later. We'll figure it out later. Then we can start making our color table v1, I guess. Who looks like this. And is there some sort of like clever macro we can do here? Delete word end paste comma boom 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 boom. U16s are U16s, offset 32s were U32s. Beautiful. And then we are looking for things in the range of A to Z uppercase, and we are trying to replace these with their lowercase equivalents. So there's probably actually some intelligent macro we can do here too, actually. If we're smart about it, it's like you record a macro that goes next underscore swap case. Oh yeah, beautiful. Boom. Okay. So we should be able to parse this thing now. We should be able to do the same thing here. We have like color table v1 or something is fix endiana stood mem bytes to value color table v1 of the color data bytes. That seems like it kind of matches. And then can we print out the color table? Okay. Okay. Version 1, num base glyph record 0. Base glyph records offset 0. That's consistent. Layer records offset. No, so we have none of these. We do have a base glyph list and a layer list, clip list, and then these things are 0. Okay. So can we look at these? So this guy, oh my god, I hate when zooming just changes where I am. Holy shit, dude. That's, oh I fucking hate. Oh my god. I think that when I resize, it shouldn't just fucking randomly scroll me around, man. Okay. So I guess that's probably just like the header, right? So this, yeah, the color table begins with a header. Then presumably the rest of the data is like in this same table, right? We see like a massive table here, but we've only parsed like however many bytes this is. So presumably these offsets are talking about like from either the beginning or end of the header, maybe. Where is like the actual data in here, right? So first of all, which things do we have that aren't null? Glyph list, base glyph list. Offset to base glyph list table. Okay, cool. We have a layer list. Offset to layer list table from beginning of the color table. Got it. Okay, so I guess we have to start just knocking off what each of these things are. Okay. Base glyph and layer records are required for color version 0, but optional for version 1. So we do not have base glyph records, right? But we do have base glyph lists, which maybe is like some sort of extension to the original base glyph records. Yeah, so the version 1 header has to be backwards of compatible with the version 0 header or something. And so it's like the version 0 had base glyphs or something, and then probably they upgraded to base glyph list, which is like a similar but better thing, probably. And they haven't, yeah, there's something to do with that. Okay. Can we start looking at base glyph list? Here we go. Conceptually, very similar, like we said. Providing records that map base glyph to color glyph definition. The color glyph definitions that each refer to are significantly different, however. See graphic compositions. Okay, introduction to 2D graphics concepts. So we have shapes, fills, layers, composites, and affine transforms. Jesus Christ. Shapes are obtained from the glyph outlines in glyph table. Oh, interesting. Okay, so our colors are maybe like I don't understand. So shapes are obtained from glyph outlines. Interesting. Interesting. So does this guy start telling me what the glyph ID of the base glyph? Interesting. So this guy is going to tell me some glyphs in the glyph table that I can look at. And I'm going to try to draw those glyphs and maybe fill them with my color? Would be my guess. That would be my guess, but we'll see. Must be sorted, increasing glyph ID order. So my understanding up until right now was that glyphs in the glyph table map to Unicode character IDs. That's how we've been using them so far, I believe. But maybe here it's different. Or maybe they just look for glyphs that, maybe they like reuse IDs that aren't going to be used for Unicode, maybe? We'll see. Okay. The paint table reference by this is the root of the graph for the color glyph definition. Interesting. Okay. I guess what I want to know is if I start with the upside down smiley face character code, which is what? Unicode upside down smiley face. Like, can I just look that guy up directly in... Oh my god. Where's the fucking character code? Where's the character code? There's like fucking 3,000 things on this page. Here we go. So like, what I want to know is my entry point is this number, right? So the question is how do I get from that number to this stuff? We haven't got there yet. I guess maybe that is his glyph ID, maybe in here? Maybe. Layer lists. So somebody's got to link like glyphs to, or like the Unicode character to a color and layer list and glyph, right? I think I also saw someone when I was looking at this the other day that this is like the color table is used in combination with the CPAL table. All color values are specified as entries in color palettes defined in CPAL. So CPAL is just the palette, right? This must be literally just like what colors are. Yeah, so we probably just ask for a specific palette ID so that we don't have to like keep saying yellow over and over again or something, right? Okay, let's actually, maybe we can start reading this a little bit. So they talk about how color glyphs are used to refer to a graphic combination. Processing of the color table is done on glyph sequences after text layout processing is completed. Sure. For example, the grinning face emoji. Suppose an emoji font in the CMap table maps this to glyph ID 718. Assuming no glyph substitutions, glyph ID 718 would be considered the base glyph. Suppose the color table has data describing a color presentation for this using a layered arrangement of other glyphs with different colors. That description and its presentation and result would be considered the corresponding color glyph. Okay. Oh, okay. So I forgot. Okay. So the CMap table takes us from Unicode number to glyph. Then the glyph table will define the shapes. Okay. And then I guess we parse the color table and maybe do some sort of like backwards lookup or something. Unclear at this moment. So maybe we start. Maybe it actually makes more sense to start with the glyph table and like trying to just see what the glyphs for this guy even look like. Yeah, let's do that. Let's say at 24 what was it? 2455? Yeah. Let's look at glyph for upside down smile. Okay. So from what we looked at the other day, we were looking at the like character map table, and if I remember correctly, the lookup that we are doing right now when we try to like render a character. So we're going to call layout text. This guy is going to have some layout helper. He is going to do some sort of Unicode parsing of this thing, and he's going to get some sort of Unicode code point, and he is going to ask the text renderer for information about that thing. This is about like glyph bounds. I think that when he does the actual rendering, it's somewhere else. It's like here he renders it into some texture that's reused later, like reused for all instances of the same character. Here he calls glyph for character, who looks up in the CMap table, which is character map. He's like, which glyph is associated with this thing? Now, if I remember correctly, there is this thing called CMap subtable 4, which says, hey, here are a bunch of ranges of character of like codes that we have in our table. But all of the lookups are done with U16s, but this code point for an upside down smiley face is like above the U16 max. So I believe there's also a different subtable for this thing that can be used for larger numbers, if I remember correctly. So we say read subtable. In here, I wanted to look at this thing and see where is the subtable for format here. Can we say for each of our subtables, for each of these guys, can we print what format we have here? So we should be seeing some with format 4, but then also some with a different format. Oh, hold on. Hold on. I want to print them all. So I guess we just do this somewhere else. Hold on. We just do this loop again over here. And we do from here, and then we print std debug print have subtable with format this thing. Okay. So here we have subtable format 4 and format 12. So if I remember correctly, format 12 is basically the same as format 4, but with an extension to use 32-bit ranges. I think. Let's take a look. What is format 12? This is the standard character to glyph index mapping table for fonts supporting Unicode character repertoires that include supplementary plain characters U16 max to whatever this thing is. Fonts that include a format 12 subtable can also include a format 4 subtable for compatibility with older applications. This is not required, however. So I guess this means that I don't know if this means that format 12 is going to be like duplicate of data that's in format 4, or if like format 12 is just like only for things that don't fit in format 4. Not clear. But this seems simpler than whatever I saw in format 4. Format 4, like look at the like length of the text for format 4 here, right? Versus the length of the text for format 12. It's like it's literally just like here's the tables. Okay, so let's try, I guess, we'll say the old read subtable, wherever the fuck that's called. We'll call this read subtable 4. And then we'll also try to read subtable 12 as well, I guess. And we'll just kind of do that separately. Because I don't really know what that entails yet. Okay. So I see. We did it this way. If I see. We probably want to do something. We're gonna want to copy this. We'll do something. I don't know what yet. So we are looking for, I guess, Unicode BMP with format 12, I guess. I'm not really sure. And then I guess we're trying to implement some sort of read subtable format 12. I don't know yet. I don't know. Okay. So, I mean, we might get lucky in that it might just be that this stuff can be a packed struct or something. Right? Because we have... Oh, I see. This is like a dynamic array, which is probably why we did it this way. So I guess we want to read all this stuff. No fucking idea what's going on, by the way. We're literally just flying by the seat of our pants. So how would this work? It was, we do runtime parser, read val. This is probably like not how we would write this now, by the way. But this was written before Zig 016 stuff. Or sorry, the new IO reader interfaces. So, you know, cut me some slack. So that's format reserve. Those are both U16s. Length is U32. Language is a U32. Num groups. Okay. And then we have some sort of array of sequential map groups. So how did we do this? We have a runtime parser read array, and it looks like we just pass a type in. Okay. So map groups can, like, is this the guy smart enough to... Oh yeah, he can take any packed structure. Beautiful. So if we have like a sequential map group, it's just these, right? Pub const subtable format 12 map group, whatever the fuck this thing is. I don't know what yet, okay, but it's a thing. It's gonna look like this: start code, end code, start glyf ID. Okay, and then what's gonna happen here? This is probably fine. Okay, so then we're like, give me a slice of subtable format 12 map groups. Okay. So let's read a bunch of subtable format 12 map groups with this allocator and use num groups here, I guess. Something like that. And then we need subtable format 12 here, which we have not defined yet. All right. Okay. And then this guy's gonna have a get glyph index on here, probably. I don't fucking know, man. Don't ask me. And this thing is just gonna be unreachable for now, because we haven't implemented it yet, but it's gonna, I bet it's gonna be something like this. Okay, so what do we have? This stuff. Format U16, great. Length U32 this time. Language U32, num groups U32. And then map groups. I guess this type should live in here as map group or something. Beautiful. Okay. Okay. Sure. And now this is a subtype here. And then we just kind of put all the shit in. Okay. Num groups might be redundant because it's part of the slice, right? What the fuck did I just do, by the way? Oh, here we go. Yeah, I think num groups is redundant. Okay. So who calls this? Someone calls read subtable format 4. So which means somebody calls this guy wants to be a 12 here and a 12 here. And then somebody calls this. So can we just make subtable 12 for now is read subtable 12 because I don't know what the fuck to do with this. And then we'll kind of stash this somewhere for look skis later. I don't know. I'm sure that there's going to be a better answer to this. But I don't know what that is yet. So we're just kind of making it up as we go. Okay, that compiles, which is good. And does it run? No. Okay. Interesting. Hold on. Okay. I wonder if this set of platform IDs does not work. Like, I don't know what this check is doing. Right? No idea. But it was here for a reason. Okay, so where does this come from? Subtable. Okay, here we go. So the platform ID and platform-specific encoding ID in the encoding record are used to specify a particular character encoding. Here we go. So we have these guys. So can we say, if format is 12, can we maybe just like print what this thing looks like? Right, so we have platform ID 0 and 3, Unicode and Windows. Okay, and we were looking at 0 and 3. Those ones we liked before. But then we have these Unicode platform. So we were like 0, 3, Unicode BMP only. So we're probably seeing something else, right? We're seeing 0, 4. I see. So I guess we just have to support that for now. Who knows what this is going to be, what this is going to do? But we'll get there. Okay. So now someone's mad at read subtable 12. That makes sense because we just implemented that and it's probably fucking garbage. So he is dividing by size of t somewhere, bytes a slice, map group. Interesting. What's this thing doing? He's doing bit size of t over 8. Dun, 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 dun. What is this thing doing? Why are we crashing? Why are we crashing? So he's trying to read this stuff and exact division produced remainder. Oh, because size of t is maybe... Yeah, so we're using bit size of here. So it must be something like the packing size of the data is like packed at like an uneven interval from what this thing wants or something. Right? If we look at like size of t is this, but bit size is this. Uh yeah, I bet you it's something like this. I bet you it's something like this and this just hasn't come up yet. Yeah. So we're trying to. Did you ban him or is that done automatically? No, I banned him. Because he keeps coming back. Yeah, okay. So unfortunately, the scheme that we've been using here, to just like cast arrays from the data does not work for this. Because it wants to align these things to 16 bytes, but the like content is 12 bytes. That's annoying. That's annoying. Because I assume that this stuff is not packed that way. I assume that like it actually needs. Well, we could check, right? Can we check? Can we maybe look at the data directly? So there's probably something in here where we have the runtime parser thing in here must have data from index onwards or something, right? It's probably something like that. So can we just look at like the first like 20 bytes? Mm, it might be aligned. It might be aligned. Right? Because we're seeing like repetition in. Oh no, wait. This should be because there's three things of size 4 or something. 1, 2, 3. So it should be start code, end code, start glyph ID. Start code, end code, start glyph ID. Start code, end code. Yeah, okay. I wrote a lot of your TTF.6 to be content parsers of your own time one. Yeah, I mean, I think that this is dog shit the way it is right now. Well, not dog shit. It's just not the way I would do it right now. So there's a lot of this that is not really ideal. A lot of this is not ideal, but what you gonna do? We gotta work with what we got. Yeah, so maybe it makes sense for now, just to dodge the problem. We're gonna read this as an array of U32s. Why is the size of T16 is packed? Because I think that it's trying to become a U64, right? Because like your data of like your data types, you have like what, U8, U16, U32, U64 or something, right? And we're trying to do U32 times 3, I guess, which is not anything. But there's still some sort of alignment, I guess. Yeah, maybe we can get tricky here. Can I force an alignment on this thing? Maybe. Can you align to 4 bytes instead of 8? Yeah, that does seem kind of nicer, right? Can I force this? Zig, packed, struct, alignment. If I don't care about speed, yes. Yeah, I mean, for now, I'm just trying to get, like, whatever is, easiest. Where does that align go? Structs don't have alignments, pointers do. Yeah, that makes more sense. That does make sense. So when I'm like, give me an array of this stuff, I guess this is align bit size of t over 8 or something. It doesn't like that. 12 is not a power of 2. I see. I see. It can only be aligned to powers of 2. I guess, yeah, I guess I can do align 4. Yeah. If bit size of t over 8 is equal to 12, we're gonna hack it for now. It's just so hard to fucking hack it. Align 1. Can I do that? Does bytes as slice allow me to override the alignment? Oh, it's not trivial. Okay, here's what we do. The easier hack for now is to read this as an array of U32s. And then this guy, we're gonna say we have a map group array that has data as a list of U32s. And then we will do get at index something like this, right? Just this is the easier hack. Here we go. This is the easier hack. Return self, like, start code is self data index times 3. Yeah, like this. This is the easier hack. This is the easier hack. Okay. So this is a map group subtable format 12, map group array, data is this. Cool. And then I guess we should probably also check like len here. What's this times 3 thing plus 2? It's because this thing was supposed to be 3 U32s, so I'm just like yoinking them out of the flat array. You need to do num groups times 3. So true. So true. Yeah, we'll just do this for now. We will do this for now. Okay, now can we do something? Like, can we just print out what we get from this thing? I would like to see that it is somewhat reasonable. So if we go to our font, 3 is U24, not U32. It's 3 U32s. It's 3 U32s. And they just weren't, like, if I just threw those into 3 U32s into pack struct, just wasn't aligning nicely. It's fine. It's fine. We can hack it. Okay. Can we do something like TTF subtable format 12 now? And can we go 4, 0 to this? We have I. Can we look at the entry in this thing? I don't know what it is yet. We gotta look at something. Hello? Where the fuck am I? Okay. So I want to look at TTF, CMap subtable 12, map groups, get I. And then this is not public, so we just throw a little pub on this and on this. And then hopefully this looks sane in some way. Unused capture. Are you high? It's used right here. I can see it. I is used right here. Oh, there we go. I just didn't save. Okay. There we go. So the question is, does this look sane? And it does, right? We see like monotonically increasing values, start and end code have like ranges that look reasonably okay. It's interesting that the glyph IDs here are not monotonically increasing, but maybe it's fine, right? Maybe it's fine. So if we want to look up a glyph for our character, which is this guy. We kind of want like, what was the thing called? Like get glyph, right? There was like some sort of get glyph index in here. I assumed that we could do something like 4, 0 to the length of the map groups. We're looking for like if I is greater than or equal to the group start or whatever, and I is less than the group end code. I think it's inclusive based off of the data I just saw there. Then we return probably like group. Oh, this is start code, my bad, end code. And then we look at the start glyph ID plus I plus something, right? I minus group start code, probably, right? Something like this, I would assume. No glyph, or maybe this returns null. What does the other get glyph index do? He just returns a U16. But what happens if it's not in there? Oh, he returns 0. Okay. Okay. Oh, this should be C here, not I. Not I, C. All right. So now we should be able to get the glyph index for our sample, right? We're like, I want, get me the glyphs for the upside down smiley face. Let's take a little peek. Glyph index is this. Okay. Okay. Fuck. Expected U16, found U32. Can we incast? I hope that this doesn't also have to be U32 now. Because if it does, I'm sure that I'll fuck up something else. Wait, we're chilling. We're so chilling right now? At least it didn't crash. Glyph index 2407. Okay. Huge. Huge. Now, I don't know what the fuck these glyphs do anymore. It's been a while. So can we look for the other calls to get glyph index? Get glyph, we can just call glyph for character. Glyph for character. And so here, what we can do is we can do, let's look at subtable 12, and we'll try to get the glyph index for this character. So this character can now be a U32, right? Glyph index is this. If glyph index is equal to 0, we try the other table, I guess, for now. We try the old table. And car is less. I guess what we should do actually instead is we'll do whatever we were doing before, and we'll say if car is greater than max int U16, greater than or equal to, greater than, we will do this. Yes. Yep. Something like this. Else, we do what we were doing before. Beautiful. Something like this. We're getting somewhere. And then this needs an incast here. Okay. Okay. So now this should give us a glyph. I don't know what's in here yet, but hopefully we can do TTF, a stud TTF, text TTF, get glyph for character. Sure. I don't know, man. So we have a TTF and we have this number. And so hopefully this now gives us a glyph. I don't know what's in here. Let's just take a little peek. Let's take a little peek. Wait. No. Fuck me. Fuck me. Okay, so what's happening here? So this is looking at... What the fuck am I looking at? S. What the fuck is S? U16. So this is from switching on self, which is a loca slice. Okay. So this is the loca table. What the fuck is the loca table? What the fuck is a loca? What the fuck is a loca? Index location. The index location stores an array of offsets into the locations of glyph descriptions in the glyph table, relative to the beginning of that table. I see. So here we are saying, okay, I have the glyph index. Glyph index is this, right? We have one. Right? And we are trying to look it up in the loca table. And then presumably he's not finding it, right? Unless somebody else also returns null. Found it. Yeah, right? So that's interesting. So that kind of makes me think that there's some other mapping that we're supposed to be looking at that is different. So I want to go back to this color table stuff. Right? We need to figure out why, like, I guess, are the glyph indexes that we're seeing different? Maybe we could also print the whole loca table just for shits and giggies. So can we, where does this come from? I guess let's just double check. So we have some loca raw, and then we are converting this into some slice. So can we just do any loca? This, like, what are we looking at here? Whoa. What is this thing? So we are supposed to be indexing at the index. So this is like pairs of numbers, right? Where the fuck? Glyph range. So for every glyph? No, for every... Oh, yeah, okay. So for every glyph, this tells me, like, the byte offsets in the table. I see. Something like that. Something like that. And so, like, of course, this thing can't just have, like, that much data. Right? That seems insane. That seems insane. Like, you would have to have so much data to have byte offsets for every single character. You need, like, a more intelligent lookup than this, I would assume. Because, like, it doesn't make sense to store two U32s for every number between 0 and 2 to the 32. That's insane. That doesn't make any fucking sense. Which is what this looks like it would have to be doing, right? Oh, no, because this is for glyph indexes. So this is only for glyphs that are valid. Okay. Okay, wait, so I want to go back. I do want to look and see kind of what ranges this thing has. Can we go like 4, 0 to loca switch loca. And I don't really care what type it is. I just want to handle it correctly either way. And can we do 4, 0 to d len over 2 or something? I just want to print these two. I want to print the range. So I want to look at like two numbers here. No, this is my for this glyph index. Here are my byte offsets. I guess what I'm trying to say. Yeon San, thank you for the tier 1. 3 months and still no Wayland stream. We'll get back. My monitor broke. What do you want from me? So for this glyph index, we have di times 2 to di times 2 plus 1, right? That's kind of what this is supposed to be saying. Okay. Okay, wait. So our glyph index is 2407, right? So should we not have a 2407 here? Oh, we do. Wait, then what's the fucking problem? That's 100. That is content, right? It's not empty. Wait, why is he pissed? It seems like he should be fine. Right, because the only time this should return null is if start equals end. Which, like, it shouldn't. Right? We should be seeing... Unless I was printing the wrong glyph index? Am I high? Glyph for character. Okay. So we have glyph index here. And then we call glyph range. Am I stupid? Glyph index 2407. Which... has a range. I feel like I'm smoking crack. Bump. Start. End. What is this 41? Are we losing data here? Is this slice getting invalidated? This doesn't make any fucking sense. We must be losing something. Yeah, we must be. I don't know how that's possible. But it sure feels that way, right? Glyph for character. When we init our TTF, we see one thing. Loca gets assigned here. Okay. I want to do this same loca print later. Because I feel like I'm smoking crack. I mean, it's still valid down here. Okay. So it's only in glyph for car that this is getting fucked up? Am I fucking smoking dick? What is happening? What if we print it right here, after glyph index? Oh, okay, wait. Okay. Well, that's interesting. That is definitely interesting. That is definitely interesting. I don't understand why that'd be the case, though. It's weird that if I print not in this, can I? Am I doing something stupid like are we doing too much here? Can I do like an if true return here? Just like reduce the amount of shit that gets up print on my screen? Oh, that's so much more confusing. That's so much more confusing, right? We see a super valid table, right? Am I like, right? We see. Okay, hold on. He should print the glyph index here? Where he goes, glyph index 2407, right? Then we go to 2407, and he says, here is my range. But then we see that start 41 and 41. So where the fuck is these 41s coming from? Like, hello? Did I misread this? Oh my god. Oh, I totally glyph index here? Oh, surely this is just wrong, right? Oh! Wait, hold on. When I'm printing this, I think I'm printing the wrong thing. Hold on. I think I'm printing the wrong thing. This is, I misread this. There are not two numbers per thing. There is one number per thing. Okay. Well, that still doesn't make sense? Oh, because they multiply by 2. Why are we doing that? As this, so we do, the range is this times 2 to this plus 1 times 2. That's probably due to some packing in U16s. Oh, 29 hex is 41 in decimal. I see. Okay. I want to double check this. This seems really sussy, but maybe there's a reason that it looks like that. Let's go to loca table. And I mean, if it's working for everything else, the local offset divided by 2 is start. Yeah, okay. So if you're using U32s, they store the actual offset. Otherwise, they store the top bits of the offset to like save space. I see. So I just fucked up the printing of the table here. Okay, so that means that that there is no glyph. It's not wrong. I wrote that code. I don't care if you wrote it. That doesn't mean that it's right. And also even if you wrote that code, like even if it's right, I should still confirm, right? I think it's insane to look at code and be like, well, Greyhatter said it's right, so it's right. It's like I don't. That's fucking crazy, right? We should double check. So I think it's fine. This is how investigation works. Okay, so that lines up with something, I guess, right? There is no location in the glyph table for this character, but it has a glyph index, right? So I wonder if the color table in here will have a glyph index for that thing, right? We saw in this color table earlier that there are glyph IDs here. Right? So maybe it's something like you look at the glyph table, and if it's, or the loca table, and if it's in there, you do one thing. And maybe if you look, no, it doesn't make sense. That doesn't make sense. Well, we could read all of this a little bit more carefully. Okay. Let's see. Let's see, where are we going to find an example? We have a bunch of definition of colors and gradients and all this stuff. This feels like much more down the line detail, right? I want to know, how the fuck does somebody get to the color table from a Unicode ID? Right? They said somewhere that shapes come from outlines and right here, CFF or CFF2. Hold on. Okay, let's get rid of some of these like print spams. Debug print. Where is our spam? This one. This is the really big offender. Okay. Do we have CFF or CFF2? No. How confusing. So our thing is in the CMap table. The CMap table points to a glyph, but the glyph doesn't like fucking exist. So like, what up with that? What up with that? Well, I guess it says we have a CMap entry. I guess it's possible that we used that CMap subtable 12 wrong. We didn't really read that too closely. We did not read it too closely, so maybe we should double check this. Fonts that include a format 12 can also include blah blah blah. The sequential map group is the same format used for the format 8. Format 8 subtable. The qualifications regarding 60-bit character codes does not apply here. However, since characters are uniformly 32-bit, groups must be sorted by increasing start car code. A group's end car code must be less than the start car code of the following group, if any. The end car code is used rather than a count because comparisons for group matching are usually done on existing character code. Can we look at format 8 that he's saying it's similar to? I mean, this is just the same thing, right? I mean, seems... Okay. So... we should see glyph index corresponding to the starting character code. So, yeah, I mean... I don't see any way to parse this thing other than, like... we have the start character code, and that's maps to this glyph ID, and then the two things line up, like, 1-to-1. I would assume. But... maybe not? Maybe not? I don't know. Okay, maybe we ask the idiot. Because I'm stuck. A little bit. In a TTF file, I have the Google Noto color emoji font and am trying to parse it by hand. I see that I am looking for the upside down smiley face at this guy. Let me double check also that we did put a 0x in front of there. That'd be pretty funny if we just fucked that up. Yep, okay. I see that the CMap subtable 12 has a glyph index for this guy. But when I look in the loca table, it does not seem to exist. The glyph data does not seem to exist. Is there an alternate table I should be looking at when trying to get to color data? What is the flow from Unicode code point to color entry? Maybe he will give us some clues. Use CMap to map to glyph ID. Open the color table. I see. So the color table provides paint glyph that uses embedded paints for references and bitmaps. Glyph loca is not the authoritative source, is what he's saying. So he is saying that I just open up the fucking color table and rip that shit until I find the glyph ID. I see. We could try that. But but this guy was saying that shapes are owned by the glyph outlines in these guys. Oh, so maybe we have a glyph ID for the like upside down smiley face that is composed of many like subglyphs or something, and those are what's stored in the glyph table. Maybe. Let's take a little peek skis down here. So let's see. The records in this must be sorted increasing glyph ID order. The paint table, blah, blah, blah. Okay. So, base glyph and layer records. Is that what we have? Base glyph and layer records are required for color version 0, but optional for version 1. Base glyph is used to map a base glyph to a sequence of layer records that define the corresponding color glyph. So probably in our base glyph list, we are going to find our glyph ID, and that's going to convert into a bunch of layers or something. We could try to look for that. So do we have the color table yet? Do we have the color table yet? We have this thing, and we do print out the color tables. So I guess, oh, we have to actually parse out the base glyph list now, right? So this guy, this is like color table v1 header. And in here, we are looking for base glyph list offset. I think, right? So it's, hold on. Offset to base glyph list table, and then number of base records. Does someone not have to tell me how many base glyph list entries I have? Num layer records, base. Maybe when I jump to that offset, it will kind of be there. Maybe it's like part of the header of the base glyph list. Yeah. Okay, right here. Okay, cool. So what we should see is we should be able to jump to color data bytes from the base glyph list offset onwards. And we should, this is like the base glyph list. And we want to see some pattern. So we start by pulling a U32 off that thing. I saw there was some sort of like reader thing somewhere, right? Where did we see that? We were in read subtable 12. We had some sort of like iterator style thing that we were using. Runtime parser is what we called it, which is maybe stupid, but whatever. Whatever, we'll get there. Okay. So we want to yoink a U32. So this is the num elms. For 0 to num elms, we are trying to do something like read val U16 and then the offset. Okay. So we have this ID to this offset. ID offs. Okay. We'll do something like this. Glyph ID to paint offset. Okay. So we're looking for, what was it? Glyph ID like 2407 or something? 2047? Beautiful. Beautiful. So it seems to me like this color table has this like base glyph paint record where in the paint table we should find something for our guy. Right? This number here. Okay. So what the fuck is a paint offset? Offset into the paint table. So I guess where the fuck is the paint table? What the fuck is a paint table? Oh, here? No, this is offsets to paint tables again. What the fuck is a paint table? Okay, hold on. So, different paint table formats for gradients use one of the other color line formats. Oh, paint tables, here we go. These are used for color version 1 color glyph definitions. 32 paint, Jesus Christ. Paint table formats are defined. Formats 1 to 32. Some formats come in non-variable and variable pairs, but otherwise, each provides different graphic capability for defining the composition for a color glyph. The graphic capability of each format and the manner in which they are combined to represent a color glyph has been described above. Each paint table format has a 1-byte format field as its first field when parsing font data. The format field can be read first to determine the type of the table. Okay, so where the fuck is this? Like, does someone not need to tell me where the paint table lives? We have layer list, clip list, index map, like none of these seem like paint table to me, you know? You know? So these are all of the these are all the formats of the paint tables, right? Yeah. So where do these live? Where do these live? Did I miss? Unless maybe the paint offset here is an offset to a paint table from beginning of the base glyph list table. Ah, heard. Okay. Good. So this offset. So we want to go like if ID is 2047, we're just going to hack it for now, right? We should be able to yoink out the paint table for this thing, right? So this is from the beginning of the base glyph list table, which is here. So we have color data bytes from the base glyph list offset plus paint offset. And this is the paint table. Okay. So here we should be able to, we'll call this PT parser or something, because I don't know what's going to go in here yet. I don't know. Hello? Paste. Okay, here we go. Yep. So we want to look at the PT parser, and we want to read, was it 1 byte? "32 paint table formats are defined." Oh, so each one of these is a uint8. Great. So can we say, this is the format, and we can say, upside down face has format of this. Hello? Oh, here. Upside down face has format of 1. Beautiful. Paint color layers. Format 1 is used to define a vector of layers. Okay, so let's just start by reading the next 2 things from this thing, right? So we should have so std debug assert that format is equal to 1. We'll do something later. How long have you been using NeoVim? Like years and years and years and years. I like so long that I have no fucking idea. No idea. Unfortunately. And then we have first layer index as a U32. Okay, like this. Num layers this. First layer index this. Okay. We're getting somewhere. We're getting somewhere. Okay, so this upside down smiley face, 4 layers. And that makes sense, right? If I were to draw the upside down smiley face, I would have 1 layer here, 2, 3, 4, right? That makes sense. So 4 is like a number that we could allow, right? And so now we want to look at the layer list. So here we have the layer list offset in the header, and someone is going to define me the layer list, right? Here. So this is offsets into the paint tables from the beginning of the layer list table. Beautiful. Oh, interesting. So it's kind of like, it's like we have upside down face. This is in like the color table, right? As 2047. This jumps to the paint list. And that gives us a set of layers, which will like jump back to the layer list over here or something. And then this jumps back with 4 entries in the paint list again, right? You know what I mean? This is like not really like the right diagram for this, but like, you know what I mean? It's you're jumping back and forth into the paint list, right? So what I want to do is I want to look at the layer list now and manually look for the things that we care about, right? So can we look at layer list offset onwards? And we want to rip the layer list entries until we find this value, right? These are the ones for our upside down smiley face, if we understand correctly, which we probably don't, but we might. So for each entry in here, it's literally just 32-bit offsets into the paint table from the beginning of the layer list table, okay? So this should be, we should actually be able to figure this out very easily. This should be, it's like, we skip the first 4 bytes, plus 4 times 47333. And we are expecting 4 offsets, so we're looking forward to 4 times 4 bytes per thing. Yeah, layers. And then can we look at this as a list of paint offsets? But they're all going to be the wrong endianness. We can do this. 4 plus 4 times 47333, 0 to 4 times 4. And then we can do runtime parser read val u32 3 times. 4, 0 to 4 or something. This should be the paint offset. So this is the layer paint offs. Jesus Christ. Jesus Christ is hard to track. Okay. Interesting. So maybe like 3 circles and a mouth, maybe, would be my guess. And so then we want to look at the paint things again. Right? So we wanna maybe pull out this stuff for a second that prints paint table stuff. I don't know yet what this does. So we are looking at where this thing lives. And then wherever we were doing this before, we can be like print paint table stuff. Hold on. Here. Which he doesn't like for some fucking reason. I actually don't know what's wrong here. Oh, there we go. And now we can print paint table stuff for each of our layers, right? So we are looking at the layer list offset plus paint offs. And we should see 4 sane layers. Fuck. Upside down face has a format of 10. Oh, sure. So now we can switch on the format here. And we had format 1. And this does this. And then we can kind of print the info for format 10. Okay. Sure. Blaze it. Fucking 420 Blaze it YOLO style. So can we look at paint table format 10? Format 10. So we have paint offset and glyph ID. Paint offset. Which is a U24? That's crazy. That's crazy. Is that supported by this? Looks like it. I'm not sure. That this might be sketchy. I'm not sure. I don't know if we can do unaligned reads like that. And then glyph ID. So this is the paint offset. Yeah, okay, cool. Why does this have another paint offset? A glyph outline to be used as a shape to be filled, or the outline sets as a clip region that constrains the content of a separate paint subtitle. Jesus Christ. Jesus Christ. This is complicated, man. So this references another paint glyph. So this is like, I am my own paint glyph, but I have more. And this is going to be related to some shape. Okay. 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 So this looks somewhat valid, right? We probably need some sort of like way to recurse this thing more nicely. What time is it? 1:35. Okay. So we can probably keep going here. Interesting. Can we maybe it would be interesting to print the glyphs here? Yeah, it would be interesting to get information about the glyphs. Now that we have shapes, right? We want to look at those in some way. The problem here is that like we've kind of sidestepped a lot of the like nice tracking of this stuff, right? We're kind of like trying to bypass actually doing this properly by looking at glyphs manually, which we can do. We can do that, right? Let's look at glyphs 4133 to 4135. Right? We should be able to do that, actually. Right, we should be able to just call TTF glyph get glyph common or something, right? I don't know. So what was it? 4133. Right? This is the glyph index. So I guess we want to look at 4133, 4134, 4135, right? These are our glyph indexes. Let's take a little peek at the headers. We're hoping for something that resembles circles, right? That's kind of what we're hoping for right now. We don't know how, but we're just hoping to somehow get to somewhere that looks like a circle. Oh my god. Glyph indexes. Oh my god, not marked pub. Fine. Holy fucking hell. Holy shit. Number of contours 16,000? 1,000? 1,000? Holy fuck. Okay, what is a simple glyph? Holy. What is this? Oh, is this like in order to draw a circle, you need a lot of individual Bezier points? Endianness? Yeah, good shout. Maybe I didn't fix that. No, because getGlyph common is already used. I mean, that seems fucking crazy to me. But like, at the very least, the X min, X max seems consistent. Like the mins and maxes are consistent values, which makes me think that these are correct. You can draw a circle with one curve if you allow t greater than 1. You need like 4 Bezier to draw a circle. Yeah, I mean, they might be doing. Who knows what they're doing in here, right? Who knows? Can we render a glyph? How do we do that? Right? Because somewhere we have like a text renderer that does that, right? So it would be interesting if we get to the point where we could just like render the glyph itself, if that's like a thing that we do. We have, I think it's in here somewhere. We have like a glyph atlas that tries to add characters to the atlas if they're not there. And then in here we have, ooh, glyph for character returns a simple glyph. So if we can get a simple glyph, then we can call this function that renders glyph at 1 pixel per f unit, and then we can print that, we can like write that to a ppm or something. Yeah. If all of this works, we just need to return the simple glyph instead of the glyph common, if that's possible. So I guess we just call get glyph simple instead, and then hope for the best. Does this do any checks? Someone must, right? I mean, I guess. I mean, let's just hope that it's fucking simple, I guess. I don't know. But this guy wants a start and an end. Where does that come from? The glyph range here. So we're assuming that the glyph range, I think that it's just the same, right? I think that these 3 glyphs are single because like we saw 1 number per. So it's got to be get glyph simple, like kind of like this. And then he also wants like an allocator probably. And we're just leaking everywhere right now. Leaking all over the place. Okay, bad news? Index out of bounds at TTF zig. Bad news bears. Oh, are these in bytes? Oh, they are. Wait, hold on. Oh, fuck. Wait, then what were we printing before then? Oh, these need to get pulled from loca, maybe. Yeah. TTF loca. I think, right? That's how this works? Get glyph index loca glyph range. That's what I'm looking for. Am I fucking high? Why is this not working? Oh, because it's in public. I see. I see. Okay, let's try this. So we have glyph index here, who gives me the start and end offsets. And then we can call TTF. What was it? I already forgot. Glyph for character. Okay, yep. We're getting somewhere. And then we have start offset, end offset. That makes more sense. Okay, let's try that. Expected type U16 found U size. Okay, so int cast here. Fuck you. And or else return error no glyph. Wasn't it glyph simple? I don't remember. Maybe. Unused local constant. Expected type TTF found either here. Am I fucking high? Yeah, it was something glyph simple or something. glyf for car was calling get glyf simple. Here we go. There it is. Is he like that now? Unused local content? I'm literally trying to print it right below. Am I fucking high? Ah. We'll call it glyph simple. We got some fucking glyphs, baby! We got some fucking glyphs! Wait, okay, so someone should be able to render this shit. It was in Atlas, right? Glyph Atlas. So add character to Atlas. Right, it was this. This is what we wanted. So now we should be able to render glyph at 1 pixel per F unit. And then can we print? Oh, we're so close. We're so close. So can we maybe do something like ppm is stood fs current working directory open file, you know, test ppm or something. Create file, I guess. And then we have ppmw is ppm writer with writer buff. Our writer buff is some buffer. We do ppmw interface as a little binding here. And then we should be able to do something like print our little ppm file format. So probably some width by some height. Which is probably like canvas width and canvas height or something, I assume. It looks like canvas does have a width, but he does not have a height. Does he have like a calc height? He does. Okay, beautiful. And then we should be able to go like 4 canvas pixels. I assume that this is like white. Oh, yeah. What do they render? What are we render in here? Yotomi, thank you for the prime. Much appreciated. So each pixel is what? We probably are ripping through Y. And then we're mem setting white between areas. So this is grayscale white. So we should be able to be like W right byte pixel 3 times, which is probably not the way you're supposed to do this, but I don't give a fuck. And then try W flush, and then okay, we're getting somewhere. This needs to be oh, this is GS here, not glyph. Okay. Did I forget to write try here, maybe? Okay. Well. 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 I mean, there is something that resembles something in there. But sure, I mean, it's hard to know if this is like some sort of like fancy mask for something. Well, can we only look at one of them for a second? Okay. I mean, that's a thing, right? That is like a shape. What about the other one? Oopsies. I wanted 4134. 4134. 4133. Well. Okay, so I was hoping that this would be like the smiley face, right? But it's clearly not. But it's hard to know if these are like clamps for other things that we like. I suspect that these are complex trees of things, right? So I think that what I would really want to see is like, I want to see the whole, I want to like navigate the whole tree of this stuff, right? Because we know, we like, what did we draw? You know, we have like the color table points to the paint list points to the layer list points back to the paint list, and like at some point in the paint, like these paint lists will have like glyphs, right? In here. And what I would kind of like to see is like the whole tree of everything that it draws, right? Because like I think that we saw when we were looking at the format table here. Where was it? COLR. Like, format 10 is used to specify a glyph outline to use the shape to be filled, or equivalently a clip region. This outline sets a clip region that constrains the content, right? So these squircles that we're looking at are not actually a thing that's being drawn. These are clip regions for something else, right? And then these like recurse back into the paint table, right? So like what we are actually seeing is we would then see like more like recursion this way, right? And so I would love to see kind of like the whole stack, and then maybe we can see some interesting shapes down the chain. But we're like, the thing is like, we're not really set up well here to do that. I think that I kind of have enough of like an initial idea here of what needs to get done that we can kind of start refactoring the font file stuff to make it easier to access the stuff that we want to access, and then we can come back tomorrow or the next day and try to take another run at getting the like shape data out of this thing. You know what I mean? Like I'd rather spend some time doing some cleanup now to make the rest of this investigation easier. I think we have like a good enough initial idea of what these things are, at least to like poke a little further later. Yeah. So we still have not found Mr. Upside Down Smiley Face. We have not found him. But we have found the start of something that resembles doing something. We have found that there is a color table. This color table is where we find... Okay, wait, we found that we have to parse subtable format 12 in the character map lookup to get a glyph index. We found that previously we only got glyphs according to the glyph index by looking at this location table thing. The location table for this glyph, the upside down smiley face, is undefined. So instead we look in the color table. In the color table, we find a glyph mapping to a paint list. That paint list may shoot back to layer lists, and the layer list will shoot back to the paint list, right? So we've kind of found like the entry point to the guy. We have not figured out how to like parse the whole chain of stuff that thing does, but we have found the entry point, which is pretty good. And so I think that we can say that what we did today is we found, if we were like, where the hell is the upside down smiley face? We kind of found it. We did not find what the hell is the upside down smiley face, but we kind of found where he starts. So I think that's like, it's something. We can call it a success. I think we've made a lot of progress. And we should just come back tomorrow or the next day, depending on how long it takes me to do cleanup here, to actually start drilling down and like actually render it. Cool. Thanks for watching, guys. If you like what you saw, we'll come back in a day or two and keep going. What is that font? Google Noto emoji color font or something. Oh geez, I just tuned in and we found the upside down smiley face. Sounds like a success. Well, we found the upside down smiley face start. We have not drawn anything that resembles him in any way, shape, or form. So we have a lot more work to do. Thanks for watching, guys. YouTube, peace out. Twitch, let's find someone to raid.